Hello viewers, Assalamu alaikum. Welcome to my first tutorial on artificial neural network. Let me introduce myself. I am Fayed bin Shokotonik, currently studying in electrical and computer engineering at Russia University of Engineering and Technology. So before getting into coding, we will explain some theoretical explanation about artificial neural network. So we will first calculate forward propagation in artificial neural network. How do you calculate forward propagation? We have input features x and their corresponding weight w. Here we take 4 input features and their corresponding weight w1, w2, w3 and w4. So we will calculate z first. So we define z is equal to wx plus b, just like a linear relationship here. Then we will pass it through some activation function sigmoid, which is non-linear function. Sigmoid of z can be calculated as 1 divided by 1 plus e to the power minus z. Then we will calculate cost. We define cost is equal to half into a minus y whole square, where a is equal to our output value and y is equal to our ground truth level. After calculating cost, then we need to update our weight. So here is two parameter w and b. W is equal to w minus alpha times of del L by del w, and b is equal to b minus alpha times of del L by del b. So in order to update weight, we first need to calculate del L by del w. So how can we calculate del L by del w? It's actually in backward propagation. We actually calculate del L by del w and del L by del v. So in order to calculate backward propagation, we need to have the algorithm gradient descent. So what is gradient descent? Gradient descent actually in derivative. If you are good at calculus, then you can easily derive these functions. So I won't describe this derivative actually here. You can go through this derivative actually yourself. I told you, if you are good at calculus, then you can easily derive this. So yeah, let's get back to coding. See how can we implement this artificial neural network here. Actually we are predicting virus. We have 4 features, then we and some weights, 4 weights. Then we will calculate forward propagation. Then we have cost function. We will calculate cost. Then we will backward propagation. Finally, they will predict our output as 1 or 0, or MN is predicted with virus or not. This is the result of our model. So get back to coding. So you can see input features and target here. Input features actually define that we have 4 features and M training example. Here actually M is equal to 8. That means we have taken a training size of 8, and we have their corresponding output target. So actually it's a ground truth level. We know for each data set, we know the corresponding output, whether it will be 1 or 0. So we first keep this input features and target into secondary variable x train and y train. So here we can see the shape x train dot shape and print y train dot shape. So here you can see 4 into 8 and 1 into 8 is the dimension of x train and y train. 8 is actually training size and 4 is input feature, and as our output unit consists only 1 unit, so here is 1. So we will first calculate sigmoid. Actually sigmoid A is equal to 1 divided by 1 plus and p dot ex p minus s. Here is our sigmoid, and derivative, actually derivative is the same. First you need to calculate sigmoid, then the derivative actually dA is equal to A into 1 minus A. So here is the sigmoid derivative. You actually can derive yourself that it should be A into 1 minus A. Okay, fine. We calculate sigmoid and sigmoid derivative. Then we will get back to here. Suppose we have a training model model function which will train our model. It takes parameter x train, y train, and learning rate and number of iteration. So number of iteration actually means that we will iterate through 1000 times, and we will calculate forward propagation, update our backward propagation, and update our cost, update our weight and cost. We need a learning rate 0.333. Why we need learning rate? Here you can see the update w is equal to w minus alpha times of del L by del w. Actually alpha means here learning rate. Learning rate actually refers to how you actually learn your model. Is it fast or is it slow, or you are taking a baby step or a giant step? So it's a very it's a hyperparameter. Actually you can tune your hyperparameter learning rate. So first we want to calculate our model at okay, fine. So here we will iterate so through the 100 times. So yes, epoch for each epoch in range, that means we will go through 1000 times. Then we will actually first calculate forward propagation. So what forward propagation is returning? Z and A. So we will calculate Z and A is equal to forward propagation. It's take parameters W, X and B. So here W and B, W is actually weighted matrix, size of 1,4, and B actually 0. So we'll pass it through forward propagation. So for propagation we call here, then function is here. Actually we will calculate this for propagation. So Z is equal to np dot w x plus b, and we will pass it through some non-linear function, activation function. It is called sigmoid. See, then we will return this. Okay, for our propagation is complete. Then we will calculate cost. Cost is equal to compute cost, which will take parameter here a and y. So we will pass it a and y. We will append this cost to our cost array. Okay, fine. So here let's compute the cost function. Compute cost. Cost is equal to np dot sum. Cost. So we completed our compute cost function. Then we will compute backward propagation. So backward propagation is returning dw and db. So dw and db is equal to backward propagation. So it takes parameters z, a, x and y. Here you can see z, a and x, y. So let's come to this. And so how we calculate backward propagation? Backward propagation calculation is right here. You can see first you have to calculate del L by d, del A, del L by del Z, and del L by del W and del L by del V. I will do this here. So first you need to calculate del A is equal to A minus Y, del Z is equal to del A into sigmoid derivative, actually sigmoid derivative Z. Sigmoid derivative is here. Sigmoid derivative. Then we will calculate dw. Dw actually dz. Actually this is the right formula, dp dot dz, and our input feature 6. Transpose, we have to take transpose. Okay, fine. dv should be np dot sum dz x is equal to 1. so we keep dips equal to true. So here is our backward propagation. One last thing we need to do is our training size is m y dot shape 1. We need to divide this through dw and db through divided by m. Okay, fine. So we completed our backward propagation. Now we have to update weight according to learning rate. Learning rate into dw, and b should be updated like this. Learning rate into dv. Yeah, we completed our everything. Let's run all this. Yep, we have run. Okay, nothing error. So if we want to plot our cost function, so you can see here our plot function. Now if you want to predict if you want to predict, so we need to define a function, diff predict function, which will take input x of weight and b. So here is something, here is the same. We will calculate forward propagation ZNA. ZNA is equal to forward propagation. Forward propagation is taking wx and b, wx, x and b. So we will return actually our calculated a. So if we want to predict our training size, a is equal to predict our x train. So we need to parameter x train, pass x train and w and b. So we want to print a and our level train. Here you can see 11001 with corresponding output is 0.64. Actually we can take it 1.51, you can 1.6, it should be 0. 0.61, it should be 1. So it works actually. You can check manually. That's it. It is the virus detection code.